This is question 19. Here we're given the diagram shows a sketch of the curve y equals sine x for values of x between 0 and 360. We're then told the exact value of sine 60 is root 3 over 2. And we're asked to write down the exact value of sine 120. So the first thing to know when looking at trigonometric graphs, and this is what this is, it's the graph of sine x, what we first need to do is remember that these graphs have a line of symmetry. So there is a line of symmetry which passes through the peaks of these sine or cosine, depending on what it is, these waves. Okay, and this graph will just continue on and continue on in exactly the same manner, with that line of symmetry going through the peaks of the waves. Now, what I then need to know is, well, what I can then say is that if I've got a value here, then this is simply a line of symmetry. It just means that if I know this value here, and I know this distance from 90, then I would be able to say what that value is on the other side just by using symmetry. Now, what I can see here is that I'm given that sine 60 is equal to root 3 over 2. So 60 degrees. And I'm told that when I read this off the graph, that it gives me, so if I were to read up from 60 and go across to y, that it would give me root 3 over 2. Now what I can then see is that the difference between 60 and 90, that there is a difference there of 30. So that means that if I were to travel 30 degrees the other side of 90, because of this line of symmetry through 90, that if I were to read up from 120, that would give me the exact same value as 60 would. Because of that line of symmetry, because it's 30 onto 90, 30 again onto 120, so what we can say is that it's just a reflection in that line that I've drawn earlier. It's a reflection in sine 90. So that means that if sine 60 is root 3 over 2, then sine 120 will also be root 3 over 2. So first answer would be root 3 over 2, same as sine 60 because of that line of symmetry. Now if I now look at sine 240, well that's over here. And again, this is just a little bit about symmetry here. Now this wave between 0 and 180 is just repeated between 180 and 360, but for negative values. So if I again look at my original value that I was given and see how does that link to what I have got now, sine 240, well I can see that this is again 30 degrees away from 270. So if I were to read downwards to the graph to find my value of y, then that's simply going to be negative root 3 over 2. For the reason that this wave is just repeated, but it's just repeated below 0, between 0 and negative 1, as opposed to between 0 and 1. So first two answers there, root 3 over 2 and negative root 3 over 2. For part B, we're told that on the grid below, sketch the graph of y equals sine of 2x for values of x between 0 and 360. So if we take a look at this here, what we need to recognise is that our change here between y equals sine x, that this has happened to the x. And so what we can say when this change has occurred is that the amplitude, the amplitude is unchanged, so the height of the wave is unchanged. So our height of the wave here is 1, so that has remained unchanged, but the frequency of the wave will have doubled. So that means that rather than drawing a graph that looks, that goes from 0 up to 1 at 90 and then back down to 0 at 180, the frequency has doubled. So it will reach its peak twice as often. So it will reach 1 at 45 degrees instead of 90, and then it will reach -1 at 135, and so on. So let's draw this properly without having that in the way, and it's just going to give me a wave that repeats twice as frequently. Okay, that's the best I could do, but obviously you could do this a little bit neater. Final thing to say here is when we see a transformation of the sine graph, what we just need to look out for is where has the change happened. The change has happened to the x, and so that affects its frequency. If we had, for example, y equals 3 sine x, then that would affect the amplitude or the height of the peaks. So it just would mean that the peaks have been multiplied by 3. So our final answers here are √3/2, -√3/2, and the graph that we need to draw looks a little bit like that.